Hey, what's up guys? This is part 3 of the video for section 1.6, which is relations. Now, the next big idea is to actually understand how to read a graph from one of the quadrants in a coordinate plane. So if you guys look at the screen here, I have 4 different graphs and they have lines in those graphs. So when you guys actually start reading graphs, and this is, I know this is not English, but in mathematics, we do read graph, we read equations, we read different things. We read functions. So when you guys actually have a graph, you can know what is happening in that graph if you understand the direction of the graph, which means the line. Sometimes you guys have a curve, but that's what it is, a graph. Now a graph, you can think it's just a picture of something that's happening. So when you guys look at this graph here, and this is just the first quadrant in the coordinate plane. You guys have the x-axis and the y-axis, but this is just positive values for the x and the y's. You guys have the second quadrant on this side, third quadrant on this side, fourth quadrant this side. But right now we are just talking about the first quadrant. If you guys have a line going up like this, we say that whatever this represents is increasing. For example, you can have sales in a store, in a company, the sales are increasing. If you guys have this line kind of steeper than this black line, so the red line is, notice the steepness is higher, we say that it's increasing very rapidly. So the sales can increase rapidly when something comes out, for example, a new cell phone, the brand new iPhone cell phone, you guys can have the sales increase rapidly, or sales can also go down, decreasing. If something is not as popular as before, the sales decrease because people are not buying it anymore. Or you guys can also have something that is constant, that is not changing. For example, if you guys are driving a car on the highway, there's a maximum speed 70 miles per hour. And nowadays the cars have a cruise control. So the cruise control helps you keep the same speed all the time. If you turn on the cruise control, you guys will drive at the same speed for the rest of the trip until you turn off the cruise control. So this is constant, which means there's no change. So if you're driving at 70 miles per hour, 70 miles per hour, 70 miles per hour, every second that passes, that's constant. You're not changing the speed. So your speed will stay flat as a line, just like this horizontal line, and it's constant all the way until you guys turn off the cruise control. Now let me give you guys an example where the speed goes up and down. If you actually drive in a city, you guys have stop signs, you guys have stoplights, different sections of the city have different speed limits. 35, there's some of them 25 miles per hour, some of them 45 miles per hour. So your speed is increasing, decreasing, increasing, decreasing. So that's not constant. It's going up, down, it's going up, your speed is going up and down. So when you guys start reading a graph, you really have to know what is happening on the graph. You have to understand what the problem is. You have to know what the graph represents, and then you guys can explain what is happening to those graphs. So let me show you guys here. I have 2 different graphs. One of them is representing a bike ride, and the next one is representing driving to school. So in the graph, this is the first quadrant. The x-axis, it has a name. The x-axis represents time, and the y-axis represents the distance for this graph. Over here is the same thing. You guys have the time and the distance. So you guys can represent what's happening to that person that's riding a bike or is driving to school when you read the graph. Now, what I want you guys to do is to write down like a paragraph. Doesn't have to be long paragraph, doesn't have to be 2 paragraphs, but just a paragraph where you guys describe what's happening in each graph. So let's look at the first one here, which is bike ride. So this is just an example of what this graph represents, there's a lot of stories or the way you guys can describe the actual graph. But it says here, from home, I went to the store on my bike rapidly. So the origin, which is the starting point, that's home. The person or I started riding my bike really fast to the store. So this is the segment or the piece of the graph that represents that. From home, I went to the store really rapidly. When I got to the store, I spent some time choosing what I wanted. So this right here, it means that I was in the store choosing what I wanted. Now you have to understand, notice that we do have the time and the distance. So from home, I went to the store. So the distance right here on the Y value, it's changed. It was increasing and then it was constant. So the time was actually running. No, remember that time, this is real life. It doesn't stop. Time keeps going and going. So the time keeps going and going and going, but the distance didn't change. So that means that I was in one place. So from here, from home, I went to the store and I was at the store for some time. But when I got here, I started going to my friend's house. When I finally paid, I went to my friend's house. So from here, I went, and you guys can actually say, I went to my friend's house really fast because it is increasing rapidly again. So that's one way you guys can describe what's happening to the graph. It's increasing, it's constant, so this is increasing. The distance is increasing from home to the store, and at the store I didn't went anywhere else, but then I went to my friend's house, so the distance was more. So from home all the way to my friend's house, it's a long distance. Now for this graph, you guys have driving to school. So that's what the graph represents, someone driving to school. And we have the time as the x-axis. You guys see the time here. And the y-axis is your distance. So one way to describe this graph is the following. It says here, I woke up late to school, so I got ready and drove really fast. So from here, the origin, that's home. I woke up and boom, I went really fast to school. I got to a stop sign right here. So this little segment, it represents that I'm not moving. So the time is running, but that's when I got to a stop sign. And after that, I had some traffic on the way. So this segment, notice the steepness is not as steep as this one. So this is somewhat steep, but not as much as this one. So I'm driving really, I don't want to say slow, but not as fast as here. And so this represents as traffic, and I got to another stop sign. So I have to wait and wait and wait. And finally, after that, I drove carefully to school. So I woke up late to school, I drove, I got to a stop sign, I had to wait. Then there was some traffic, so I didn't drive that fast. I got to another stop sign, I had to wait. But then I drove to school carefully, which means I didn't drive really fast as the beginning. So that's how you actually represent graphs. You read and you check what they mean when you guys have the x-axis and the y-axis. So let's go ahead and look at a couple more here. We want to describe what's happening in the graph. So we do have one graph that has sales for the y-axis and time for the x-axis. And notice this is a very weird shape right here. And then we have like a curve over here. So we have the height on the y-axis and the time on the x-axis. So you have to know what they represent. So here, in common sense, the more you go up, the more sales you have, and time is just running, never stops. And over here, you have the height. The more you go up, the higher you are, and time never runs. So let's go ahead and just look at a couple ways you guys can represent the two graphs here, and you guys have the following. So for the graph that you guys have sales, you can say the sales started good. So here from the origin, they went up. So that's good sales. But then they became constant. So people were buying, but there were not a lot of sales, just same sales over time. Now in sales, time You guys can talk about weeks, months, or years, because that's how you actually know if the people are buying, not hours. You guys can know how many people are buying an hour, but companies, they want to know what's happening over time, so weeks, months, or years. So the sales increase, very good, but then it became constant. At this point here, the sales increased really rapidly. So that means that they became popular. That product that we're selling, it became really popular. So people were buying more and more. But then it got constant again right here. And when it got to this point, so here it said the same, the number of sales said the same, constant, didn't change. It decreased. So here, the first section, it decreased really fast. It went down. The sales, boom, dropped really fast. But when you guys look at this point right here, after this point, it decreased slower than this one. This is really rapidly. So it went down fast and then it went down kind of slow. So it went down all the way to 0 sales. So this product, it was good and then not great. It became really popular and then people were just buying it, but then it decreased. So it became unpopular. No more people were buying it until it reached 0. Now the next graph, you guys have height and we have the time. Now you have to understand what this is. First of all, we do have a curve. So notice that the curve is here. The curve doesn't start at the origin. So that's not the actual starting point. The curve starts right here on the y-axis, which is your height. Now, you guys need to make sense of this graph. Since we have the height, well, you can say the origin 0, that's the origin, is the ground, which is no height. When you guys go up the height, that means that you guys are above the ground. So you guys can be on a chair, you guys can be going up an elevator, up the stairs. You guys have a house, you go to the second floor, or you might go all the way up on top of the house, which is the roof. So you guys can be above the ground. So this is what it means. This point here, it means that it's above the ground, not at the origin. It's somewhere above. Now, one thing that you guys can say is a ball is thrown from a roof of a house to the ground. That's what it represents. If you guys think about it, a person can be on top of the roof with the ball right here. So it's above the ground and the person throws the ball, and what is the actual path of the ball? It makes a curve. When you guys throw an object or a ball into the air, it makes a curve, and whatever goes up, it must go down. So that's one of the rules that we have here in real life. So which gravity takes place. So you guys have the object going up like this, you throw it and it has to go down all the way to the ground right here. So you guys can have the time, you can know how long it takes for the ball to hit the ground. From the roof of the house, the ball is thrown and all the way to the ground. So that's why it hits a curve. When you guys look at the path of the ball, you guys make a curve. So this is how you actually describe graphs. You have to make sense of the problem. You have to understand what the x-axis means, what the y-axis means. You look at the actual path or the curves in this case, or the actual shape of the graph, and you have to understand how you can describe what's happening to that object. Alright guys, so this concludes my video. Make sure you guys practice. If you guys like my videos, you can hit that like button. You can also subscribe to my channel, and I'll see you guys later.